Okay, let's go. So, hello everyone. I want to talk today about our experience in the past years, what we did with developing operators and running operators in production. So, let me introduce myself. I'm Sebastian Scheele, one of the co-founders of Kubermatic. My background, I studied computer science, was then working several years for SAP and started the company 4.5 years ago. Started working with Kubernetes already over 5 years ago. And so at Kubermatic, we're mostly focusing all around Kubernetes. We have two open source projects. One is Kubernetes Kubernetes platform, and the other one is Kube1. And today I want to tell you a little bit about our story with our open source solution, Kubernetes, how we developed this, what are the lessons we learned, and where we see potentially also the future for, in general, operators in some areas. So let's start really how everything started. So let's go back to 2016. Kubernetes was quite new, and so we were working with customers who want to run Kubernetes on different platforms. So they wanted to run Kubernetes everywhere, on different cloud providers, but also on-prem and many more. And so one of the challenges was really, how do we get this up and running? At this time, there was like only one managed offering available, which was GKE from Google, but all the other cloud provider didn't have an offering. And so it was every time we started using different tools, mostly what the customer preferred, Terraform, Puppet, Chef, Ansible, a lot of different ways. But at a certain time, every time created a challenge. And what we saw, there was every time customer were every time asking us the same questions. They want to have a cluster, but that's only the beginning of the journey. Then they want to have upgrade of the cluster, automated upgrade of the cluster, day 2 operation of the cluster. And so at that time, we were thinking, can't there be a better way to do this? What could be a way? So because we saw, like with the traditional approaches, there are a lot of challenges, especially if you are in a big organization and you want to centralize, provide clusters as a service inside your organization. So then every time it needs like ops to scale the cluster. There was also no generic approach which runs on all the different providers. So it was every time, depending on what solution you're using, you could reuse some components, but you need to adapt it specifically to the cloud provider. And for us, this didn't feel really really native. And also each of this specific solution, additional to the complexity what Kubernetes brings to the table, also needs domain knowledge of the specific solution. And like scaling nodes, for example, for your cluster, every time needs external tooling and external dependencies. And there was also like no generic way how to build auto-scaling. Of course, some of the cloud providers supported auto-scaling, but also if you are on-premise, potentially you don't have this capability. And but would it not be nice to have this capability? And then it was also, if you started on one platform and you want to go to the next platform, it was a huge effort to adapt these patterns, what you learned already or what you built up already on the one platform, to bring it to the other platform. And so we were thinking, how can we run Kubernetes at scale? And really leveraging cloud native patterns to do this. So our goal was then, we want to manage like hundreds or even thousands of Kubernetes cluster at scale. And it was every time we felt with the current setup, it's not working. So we were thinking, we really would like to use, or we like Kubernetes. Why can't we use Kubernetes to run Kubernetes? And but at that time, now there is a pattern called operator available, but at that time there was no pattern like operator, and so we were thinking and trying around like how can we do this, and like first manually deploy like the containers of the master on a cluster and see, yeah, that's running. So how can we use Kubernetes to automate this deployment and all stuff in a generic way, and using principles from Kubernetes for our tooling and build tools on top of this. And so we came up with the idea, we want to have a multi-cluster management solution which can manage a lot of Kubernetes cluster, where on the one way, parts of the operator is deploying stuff on Kubernetes, with like the master is running in a namespace on top of Kubernetes, but parts of the operator is calling also to external APIs to deploy VMs at the cloud provider. And I think this is already a great pattern. What we see that like operators are not only built for deploying workload on top of a cluster, it could be also used to deploy workload to talk to external APIs. And so what we really look into is like when we start building, hey, we want to have this control loop logic from Kubernetes, where it starts with like, you change a desire state, a controller sees this, it triggers in, execute some actions, compare the current state with the desire state. If in the meantime changes happens, it updates the system and reports the latest status back. And so looping this in a regular time and checking every time your current state with the desire state. And at that time, it was already working for like deployments and replica sets and pods. And so we were thinking, okay, what code do we need to use this again? And so at that time, we hadn't like frameworks which are available now. So at the end, what we did is like using some parts directly of the Kubernetes code to build similar controllers and control loop logic so that we can deploy things and control this. But then the question was like, again, but how, where do we store information? Because now we have CRDs. At that time, we didn't have CRDs, even though third-party resources or anything. Like, so we were looking into what can we do, where can we store information, because we need to store the desired state so that we can compare it with the current state. And we checked, and what we found was like at the namespace, we have annotations. So can't we reuse the annotation and store all the information what is required there? So information, for example, about the cluster in general. What state is the cluster? Is it active? Is it currently in deletion? Is it failing? What cloud provider do we want to use? Is it AWS or Google, or potentially on-prem, VMware, OpenStack? How many nodes do we want to deploy? And a lot of other information. This is like only like a condensed example. So like what type of machines, what user it belongs to, and many more. And so we started using annotation and labels to store this information and build our first controller and see this pattern is working, and we can leveraging this, and we are able to scale and manage a lot of Kubernetes clusters with this. And then because not only we were or wanted to use this pattern, there was a new object introduced in Kubernetes called third-party resources. And this makes a lot of things easier for us, because instead of reusing the namespace and the annotation inside the namespace, we could build up dedicated objects for all the different objects we need. So for example, we could create a cluster object, so where we describe the cluster itself with like labels, a specific cloud provider spec, and then additional having more resources like for the machines or the VMs, for the users, for in our case, we have projects where a cluster belongs to. And so with this, we could really group the objects we needed inside of Kubernetes. And the big benefit we had was we didn't need to use or deploy a dedicated database additional on top of Kubernetes and take care of additional database. So we could, as long as we're having an underlying Kubernetes cluster, we really could leveraging this underlying Kubernetes cluster and only deploying our controllers on it. And then everything is there, and you could everything control and manage with Kubernetes. And this makes the whole operation much more easier, because the only tooling what you need is like kube control and nothing else. And so with kube control, you are totally able to manage everything. Everything is stored inside of etcd. This means on the one side, etcd gets even more critical because you should take care about your etcd, make regular backups for it, so in case something happens that you can recover it. But you only need to take care about one database, which is etcd, and can really improve these processes instead of having a lot of other databases where other objects are stored. And so this turns out to be really powerful for us. And so since 2016, we are already writing operator there and using this in our day-to-day business. And then after some time, third-party resources were deprecated and replaced by custom resources. At the end, custom resources are extension of the Kubernetes API. With custom resource, you have a default way to extend the Kubernetes API. It makes it really easy to create your own objects, even if Kubernetes is not supporting it, and build additional tooling on top of it. Like in our case, we built a meta orchestrator for Kubernetes itself. And the good thing is it's completely flexible, and so it's not tied to your upgrade of your underlying Kubernetes cluster. So you can register custom resources dynamically, and so you can have an independent lifecycle of your applications which using custom resources versus the underlying Kubernetes clusters. And this really makes it powerful to work with and to operate with. And so let's have a demo to better understand how it works. So as I said, everything is running on Kubernetes. So the first thing what we developed is controllers and API for our own Kubermatic, which is like our operator. So we have a controller manager, which is taking care about the reconciling, and then we have additional components like an API server and a dashboard on top of this. And so now what the controller manager is doing, it's mainly looking for one cluster object. Where we describe the cluster, and let's create a new one. We could do this now over the CLI. I can do this. We have also a front end for it, so that I don't need to type in every stuff. I will generate this. So I want to run a cluster on AWS, providing a name for it. I can provide my credentials, or we can also define in the backend some predefined credentials, and then I can say how many resources I have, or no, how many VMs I want to spawn on AWS, and then, for example, operating system, what type of nodes, things like this. And so that's basically it. And now let's generate the cluster resource. So now we have a new cluster resource. And here you see our new resource. And now what we are doing is like, creating a namespace and deploy all the components of Kubernetes inside of the namespace. So now you see the API server, the controller, etcd, the scheduler, also a machine controller. Our machine controller is our operator, which then talks to the external cloud provider. And so after some time, we're having a running Kubernetes cluster. And so now the fun part begins. So first of all, what we could do is we could do updates. What we could do is what we are using here is deployment and stateful sets. So we could deploy a new deployment, or we could deploy a new stateful set. But we could also do even more. So let's say I'm lazy. We're running now our etcd, and by accident, I'm deleting my etcd. So now what's happening is, of course, first of all the container gets deleted. But you see already, now our controller kicks in and is restarting. Recreating the stateful set and reprovisioning etcd itself. So with this, I mean, look, this only took now a few seconds to get an etcd completely back. If you would do this on a normal cluster, typically it takes you much more effort to control this. And I think this is really the power of controller, because you can really build control loop logic around, and it can compare your desired state with your current state, and then getting your cluster back in, or getting your workload back in the state you want to describe without any manual intervention. And so with this, you can do a lot of automation around what before of this needs to be done manually, or half manually. Okay, when something is broken, you execute new commands, and then automatically some scripts are repairing stuff. But in our case, nobody needs to do something. The controllers are comparing it all the time, checking how is it going, how is it working, and after some time, everything is back up. And you see, now etcd is completely ready again. And so if we go to our cluster again, you see also here we have a complete functional cluster with VMs and everything attached. So even in worst case, something is breaking, it really takes care to restart it. And we do similar on other areas as well. So for example, on the machine deployment. So here we're leveraging the cluster API. And we also have a controller, which is every time constantly checking the replica count I have described or I defined during the creation of the cluster, if it's still every time there. And so let's simulate an outage of a specific VM. Now what's happening again, the controller is checking in it, and immediately detects there's the desired state and the current state, there's a mismatch. So now I need to create and deploy a VM again. Of course, now it takes a little bit more time because it's not running on Kubernetes. It's running on it's now calling the API of the cloud provider, in this case AWS, and it depends how fast the cloud provider is. But you also can use there the reconciling loop to manage your VMs and to manage the complete life cycle of the Kubernetes cluster. So let's look more in detail what we learned. I mean, writing these operators, we got a lot of experience with it, and like all of our code, what is written here, leveraging typically the operator pattern and reusing this pattern. And so first of all, what's really beneficial is operator can help you to automate complex tasks. It can completely automate the recovery, for example, for etcd. I mean, in our case, what I did now was only deleting the pods. The storage was still there, but I could also delete the storage. So then the operator is completely recovering the etcd from a backup and get it back to the state as it was before. So like even if you have a complete loss of etcd and your storage, and you as long as you have a backup, it can completely help you to get this back. And this is true for all other components. And so with this, you really can automate complex tasks where typically, in the worst case, when an accident happens, first of all, getting complex tasks back is mostly error prone. Because typically you need to execute some commands. You are in stress because something potentially production is down, and then even more mistakes are happening. In this case, if something goes down, it's doing it automatically and completely end to end without manually intervention. And yeah, the next thing is, because it's completely coded and automated, it reduces the risk of human errors. So you can really validate this. The code is not doing any typos. So you're getting the, if your operator is working correctly and you don't have bugs in it, you get it. You get, in this case, get it back to the state. And if you later see potentially some of the errors, your operator is not catching up, you can extend your operator and adding more and more functionality to it, so it gets more and more smarter to manage all the different errors without manually intervention, and with really helping to reducing the risk that somebody is doing errors during getting stuff back. One big benefit of using operators is it helps you really to get most out of your Kubernetes stuff. So it's not only that you can deploy stuff, you can really also deploy or manage like the airbags, the audit logging, can deploy monitoring stuff with it. So a lot of more components, and not only like, okay, I deploy a pod and that's it, really helping you to do a lot of different stuff, combining with other components of Kubernetes, for example, or with other components where you want to register, for example, your services. And so with this, you have a lot of capabilities built in your controllers to really helping you to improve your operation and help you to improve in your daily business as well. And I think one of the big benefits of operators is also it allows you to test your operators or the part you're building. So you can really write tests for this error cases the operator is facing. So in our case, for example, the etcd outage I simulated. What you can do is really in your CI pipeline for the operator development, build a test case for this. Like, for example, build a test case for only that the pods are deleted or the stateful set is deleted, or even like a disaster recovery case that the stateful set and the storage is deleted, and validate it that after at the end it's recovering and getting everything back to the state. And so with this, you get a lot of confidence in your stability of your platform, because every new version of my operator I'm shipping, I tested this cases, and I know my operator is working correctly and getting really more and more stability and automation in your platform, so that you can really start scaling over software instead of scaling over people. And now, as I said, when we started, there was not really a foundation built for this. But this changed in the last year dramatically. So first of all, there are API clients for Kubernetes. There are, for example, especially for Go, frameworks to build operator, for example, OLM or Kube Builder, so which can help you to generate skeletons that you don't need to write everything from scratch. When we started, we started like writing everything from scratch, building logic around this, but now replaced this also with the stuff what Kubernetes itself is providing us, because then we have less maintenance. We know it's tested and validated by Kubernetes itself, and so we could easily and faster develop new operators on our platform. But there are also downsides with operators. On the one side, operators are hard to write. So it's much more easier to write a Kubernetes deployment or a Helm chart or something like this. So depending on what areas you're coming, typically most of the operators are written in Go, but of course you can also write them in other languages like Java or Python, but potentially then as most of the stuff from Kubernetes and also the frameworks which are provided by Kubernetes is written in Go, potentially they lacking of some features or functionalities which you then need to implement on your own. And it really needs some time to get into, start writing operators. This is also what we see on our side. Even if the people have experience with like Kubernetes, it takes some time to really understand this pattern, the frameworks you are using, so that you are really good and can start writing operators. It also requires deep understanding and knowledge about Kubernetes. So before you start really writing an operator, you should be really familiar with how Kubernetes works, because at the end, you're heavily reusing principles of Kubernetes, and you should understand how they're working, how Kubernetes is working, and what are the specific components, and so that you can really write well your operators. Operators also provide another layer of complexity, because if you're only writing, for example, a stateful set or a deployment, everyone who knows Kubernetes understands this, or should be able to understand this, and can work with this. But if you're putting an operator on top of it, and managing then pods or other components, and of course you can automate with this a lot of stuff, but this brings also a lot of complexity with it, and especially in case of your operator is not behaving as expected, it gets more complex to debug, because then you not only need to debug your underlying Kubernetes objects, you also need to understand what is your operator doing, what the operator is manipulating, for example, with this. And for example, is the problem coming from the underlying Kubernetes objects, or is it coming from the operator itself? Especially, is there also like an upgrade of the operator, or an upgrade of the underlying Kubernetes cluster, and you have then an error, where does it come from? How do you search for it? And if you start writing an operator, you need to be sure, and it needs to be clear, you have some maintenance effort with this. It's not something you write once and can run forever. On the one side, in most cases, you start extending this, adding more functionality to it, because the goal with an operator is like really the operator should help you to automate most tasks, which you're currently potentially doing completely manually or half automated. And the goal with an operator should be it should be fully automated and reduced on the one side the effort you need on doing this manually, but also reduce the manual errors done by a person. But yeah, you need to constantly continue work on it, validate it also that it's working with newer releases, and ensure that you have some maintenance with this. So on the one side, operators really brings a lot of benefits to this, and we see this with our platform. We have customers who are managing hundreds or even thousands of Kubernetes cluster, completely automated. And we had like even customers where they had heavy outages on the platform, for example, on the underlying platform, not on Kubermatic, on the underlying platform. And when the underlying platform was coming back, the operators were smart enough to get the whole cluster back and working. And so it brings you a lot of benefits. But on the other side, there is also some efforts included, which you should consider writing operators, because if you forget to consider these operators, it will not really work and scale, and you will not get the benefit out of it, what you expected from. So there are pros and cons on both sides. And especially, I think, if you're running complex application, stateful application, where you need to deal with multiple tasks, an operator is another tool which you should consider in your tool stack to build something. Especially if you have stateless applications, I would first look into the tooling what Kubernetes provides you out of the box, if you can be using this. And only if you see, no, we're coming to the point, the part what Kubernetes is providing is not helping us, start considering working with operators. And one of the things is also an operator brings you a login into Kubernetes. The login is mostly for the operator itself. So as I showed you, an operator can, on the one side, deploy workload to Kubernetes itself. So also the workload itself can run on Kubernetes. Or the workload can also run on external components, which have an API you can talk to, and where you can get the current state back, so that your operator can every time compare the desired state with the current state. So there you don't have the login. But for the whole logic, what you're putting into your operator, there you're mostly bound to Kubernetes. And I mean, as Kubernetes becoming the standard way for cloud native application, I think the risk gets lower and lower, but you should be aware of this. So if you want to do this on another provider, or not provider, on another tool stack, not on Kubernetes, you can't easily leveraging the operator pattern for this, because the operator pattern is talking to the Kubernetes API server, and need some components of Kubernetes to leveraging this. Okay, but let's have a quick look also what comes next. So where we think operators can help in the future running and helping operating stuff. So let's look into the whole edge and IoT universe. This gets more and more traction. You see also Kubernetes gets more and more in this area, and a lot of more workload potentially in the future will not only run in the cloud, it will run again in your own data center, or somewhere more closer to your consumers. So really, I think we need to think about how can we automate from the cloud to the service provider edge up to the user edge. So currently, most of our workloads are now done in the centralized data center or in the cloud. But now new patterns are coming up more and more, and we see this more and more. And like coming up, first of all, with service provider edge, where you have like a regional edge or access edge, or telco edge, is it called, especially if we're thinking about 5G. And then you have the user edge, which starts with like on-prem data center in the fabrics or in the shop floor. But then even more smaller devices like smart devices or constrained devices, so really small devices. And I think there the pattern is really going as from the right to the left. It starts with like the big data center, but it's more and more you're going to the left. On the one side, you have more and more devices, and on the other side, it's harder to do manual tasks there because if you're in your own data center, in worst case, one of your engineers can go to the server and reboot it. If your device is somewhere out in the on the world, and so first the engineer needs to travel there, it gets quite expensive. So there, automation gets more and more key, and I think like operator can really help there to improve this automation to the next level, so that we can really manage, especially on the left side, billions of devices in a scalable way and also in a cheap way. So because as smaller and smaller the device is, as cheaper the device will be. So it needs to be more and more cost efficient to run and operate this stuff at scale. And so that's definitely where we think one of the futures for a Kubernetes operator to manage this and operate this. And with this, I'm coming to the end and open for questions. Piotr is asking if our platform is using cluster API under the hood. Yes, we're using parts of the cluster API under the hood. Using an older version and waiting that the current or the new development there is going to be to at least beta mode, that's the API, and that they are not breaking changes again and again, because with our platform, we have production workload on it. So for us, we currently have the main component what we need from cluster API, but we will also upgrade to the latest version in the future. Another question from Piotr: is there any way to buy Kubermatic as a software package that I could deploy in my own data center? Yes. So on the one side, we're providing Kubermatic in 2 versions. On the one side, we're providing a community edition. So if you go to GitHub, github.com Kubermatic/Kubermatic. Here you find our community edition, and we are providing an enterprise edition with additional features. Kubermatic is built that it can run on a lot of different providers. So we're supporting major hyperscalers, but also VMware, OpenStack, bare metal, and edge deployments. And but it's also easy to extend and building new or including new providers. Because what we have is like our machine controller, which is an operator, of course, and this is talking to the different providers. And here's also a documentation how to include a new provider. There's another question. Assuming we have dozens of operators deployed to Kubernetes, how to manage the operator lifecycle for so many instances? Should we think about kind of meta operator being capable to manage the lifecycle of this functional operators. Yes, exactly. That's what we're currently working on with our other open source project called Kubecarrier, because we saw this pattern to run a meta operator for Kubernetes is working well. So we were thinking we need this also for other operators. And that's the reason why we start Kubecarrier, managing especially the instances of an operator. Of course, also that it can deploy the operator itself. But think about if you're having clusters and you want to manage, sorry, not clusters, if you have a database and you want to manage the database and having a lot of them, you need extra tooling for this. And I think this was the last question. So yeah, feel free to use our open source tooling, Kubermatic, or if you want to start with a single cluster, which is also using operator using Kube1. And if you have any questions, feel free to reach out to me or to us, join our Slack, and thanks a lot. And see you also in the next session where you can ask further questions. Thanks a lot and bye.